Hi, my name is Hillary Olson. I am the State Soil Health Specialist for Iowa NRCS. And today I'm going to be talking about the NRCS roles, goals, and mission with carbon sequestration. Spoiler alert, when I was asked to give this presentation back in July, I thought that I would have more concrete examples and details about what the agency plans to do with carbon sequestration. They are still gathering input and finalizing those details. So today I'm going to talk a little bit about what they have done so far, but I'll also cover several other topics, including the background on carbon sequestration efforts, Carbon 101, and how carbon directly relates to soil health. I'll also talk about, again, the USDA efforts with carbon markets and some of the resources that NRCS has available. Just to give you a little background, this is a graph of the emissions by economic sector. So as you can see, transportation, electricity, and industry account for about 3/4 of the total emissions by sector. Agriculture accounts for about 10% of the total emissions, and that's a factor that's increased a lot over the last century. That includes things like our fuel usage for our implements. It also includes the energy that we use to manufacture fertilizer and the application to our soils. Also, another fun fact, I guess, is that as we apply those nitrogen fertilizers to the soil, that stimulates the microbes to release more nitrous oxide, and so that also contributes to our total emissions. One of the things that why there's so much focus on ag lands right now, is that they are estimating that the current sequestration on U.S. cropland is approximately 8.4 million metric tons of carbon dioxide equivalent. They are estimating that the potential is about 100 million metric tons of carbon dioxide equivalent per year. So there's a lot of opportunity to store carbon in the soil. Why now? Why is this topic front and center in every magazine you read and on a lot of websites and social media? There was an executive order released back in January, and this is a statement directly from that executive order that America's farmers, ranchers, and forest landowners have an important role to play in combating climate crisis, because they can reduce those greenhouse gases by sequestering or storing more carbon in the soils, grasses, and trees. And so that's a large land mass that we're talking about here. So even a small change over that large of a land mass can have a big, significant impact on atmospheric carbon dioxide. This is a chart that it's got soil organic matter on the side. It's got time since cultivation here on the bottom. So as you can see, since we've started cultivating, so I'm presenting here in Iowa. We had tall grass prairies here in central Iowa. When those were tore up and we started cultivating, that has degraded some of the carbon and the soil organic matter. It's estimated that we've lost about half of our organic matter since that time. And the reason that happens is because as we till and as we plow up those native vegetation residues, that incorporates oxygen into the system, which oxidizes that carbon, and that is released into the atmosphere. So one fun fact is that there's more carbon stored in the soils than in all plants, animals, and atmosphere combined. So as you can see, we have this steep decline there at the beginning. It's reached a little bit of an equilibrium, and now we're looking at changing some of our management practices that we're going to talk about here in a couple minutes. Changing some of our management practices will incorporate more soil organic matter and therefore more carbon into our soils. I'd like to briefly cover the carbon cycle next. So carbon is attached to oxygen in the air, and that's what forms carbon dioxide. There's 4 major processes that go on in this carbon cycle, one of them being photosynthesis. That's something that we all learned back in 5th grade science, but the plants are incorporating energy from the sun and carbon dioxide, and they are releasing exudates through their roots to feed some of the microbes. So those soil microorganisms are also decomposing organic matter. That's another major process in the cycle. So photosynthesis, decomposition, those soil microorganisms are also respiring. We're respiring, animals. So respiration is another major component. And then finally, we have combustion of our fossil fuels. So those are ancient sources of photosynthesis products. And so as we burn those, that releases that carbon dioxide into the air. So carbon sequestration, what is it? Carbon sequestration is a process of capturing, securing, and storing carbon dioxide from the atmosphere in our soils. This is sequestered through the process of photosynthesis, and it can be stored as soil organic carbon. So in this diagram, we've got a plant here that's taking in energy from the sunlight. It's using carbon dioxide from the air and water from the soil to build those carbohydrates. It releases these carbohydrates or sugars through its root exudates, which feeds our soil organisms. Again, as I mentioned earlier, those soil organisms are respiring, they're breaking down the organic matter, and so it's a big cycle that in a perfect world is in balance. So the idea is to stabilize carbon in solid and dissolved form so that it doesn't cause the atmosphere to warm. Carbon dioxide from the atmosphere enters the soil through three primary pathways: decomposing plant matter, root exudates, and the soil organisms that feed on them. Carbon can be found in different states in the soil. It's dissolved in the water in the soil solution, in large chunks or pieces, also known as particulates. It's also enveloped in soil particles or aggregates, and it's stuck to those soil surfaces. So the large pieces, we can think about those as some of our decomposing plant roots and whatnot. This third option here, where it's stuck actually in between the particles of soil and the soil particles themselves, that is where tillage really plays a role. When we break apart those aggregates, that exposes those surfaces to air, and that oxidizes that carbon, and that's how it's released. Some quick definitions here. You'll see soil organic matter and soil organic carbon used interchangeably in a lot of resources. So one thing to keep in mind is that carbon is not by itself in the soil. It's usually got hydrogen, nitrogen, sulfur, and other elements attached to it, and that's what encompasses soil organic matter. That includes, like I said, the plant roots, exudates, fungi, microbes, and the decomposing organic matter. Soil organic carbon is about half of the total mass of the soil organic matter. So those are two things to keep in mind. So I just really want to drive home this point that carbon drives the system. So what we've got here is a solar field. Now, you couldn't convert this energy from the sun to electricity without those solar panels. Likewise, we need cover crops, we need a growing plant out there. You can think of the plant leaves as little solar panels. They are collecting the energy from the sun, and they are pushing that carbon into the ground through their roots. So those are things to keep in mind. In our system here in Iowa, we have a lot of corn and beans. So incorporating cover crops will provide more of a living plant year-round. Two main practices that I want to emphasize, and in the upcoming presentations, there'll be a lot more information on these practices. But the two main practices I want to focus on are no tillage and cover crops, because if we stop or reduce our tillage, that is going to protect the carbon that's stored in those aggregates. Also, if we incorporate those cover crops, that gives us a green living plant longer throughout the year and maximizes our carbon input. So together, those are the things that fuel our healthier soils. So why is a healthy soil important? A healthy soil really starts with good structure, and that's created through things like organic matter. Organic matter is one of the primary sources of food, in addition to root exudates that feeds our underground livestock, our bacteria, and our fungi. And so they are creating glues in addition to that organic matter that holds those aggregates together. So when you have good structure, that means that when you have a rainstorm, that your soil is going to hold together instead of dissolve and fall apart. So I don't know if you've seen a slate demo, but I would encourage you to look one of those up online. Comparing a soil that has good structure versus one that doesn't. The soils that have good structure have practices like reduced tillage and cover crops, maybe some livestock incorporation. It's got a lot of glue, a lot of carbon, and it's holding that soil together. Compared to a soil that's had a lot of tillage and no cover crops, it's only got a plant growing out there for about 6 months out of the year. When you put those two samples into water, the sample that doesn't have any cover crops and had a lot of tillage will collapse and fall apart. The sand, salt, and clay particles will dissolve, and so as they lose their structure, they will, as the water moves across the soil surface, they will settle out and create a surface seal or crust. And so when that happens, as those particles of sand, salt, and clay disintegrate, they will settle out in these holes or pore spaces, and that surface seal will prevent the water from infiltrating. And when that happens, we have more runoff. You're losing your topsoil, you're losing your fertilizer and your chemicals, and everything that's on in the top soil is lost. So it's also impacts how your crops do in the middle of summer. Like this last year, we didn't get a lot of rain when we needed it. So I know on my farm, my husband and I farm, I want every inch of rain that falls. I need it to infiltrate. So if we have good structure, we have a lot of organic matter, a lot of carbon, and our water is infiltrating, that means the air is also able to exchange through those pore spaces, and that will increase our soil biodiversity, because that underground livestock is just like you and I. They need air, they need water, and so when we have good structure and we allow those things to happen, that means that they are going to thrive. They're going to have more diverse communities and more of them. And so when that happens, that means that there's more good guys to combat the bad players, I guess. So that would help you with disease and pest suppression. So when all these things are working, you've also got your nutrient cycling faster. As I mentioned earlier, soil organic matter is carbon in addition to things like nitrogen and sulfur. These soil microbes are breaking down that organic matter, and as they do, they release those nutrients in this plant root zone, and that's in an available form of nutrients for the plants. And so when you've got all of these things happening, you're going to have increased resiliency on your farm. So with this picture, this was taken in northeast Iowa. On the right, about a 1-inch rainstorm had happened previous to the taking of this picture. But on the right, there was a lot of tillage. There was no cover crops. You can see how the water is ponding up on the surface, and that's because there was not good structure. Those sand, salt, and clay particles collapsed and filled in the pore spaces, causing this to happen. And so there's going to be runoff. It's going to lose topsoil and carbon in that process, compared to the field on the left-hand side here, where they weren't doing tillage and they have those good pore spaces that allow that water to infiltrate. So soil health is really critical to all of this. These carbon markets are shining a light on some of these practices, these soil health management practices. If you're in a market, that's kind of the icing on the cake. But in my mind, if you can implement these practices on your operation, you're going to have a better functioning soil. Your fields are going to be more resilient, and you should be able to sustain your production for longer. So that was a review of Carbon 101, why it's so important and how it links to soil health. Now I'd like to switch gears and talk a little bit about the latest and greatest when it comes to ag policy. Over the last 30 years, there's been some congressional activity. I'm going to focus on the recent interest with, I'm going to cover some of the things that have happened recently, including this executive order that was released on January 27th, which has led to a number of things happening as a result. It's impacting some of our programs, such as CRP. It's led to several reports. It's involved a lot of stakeholder meetings and input from the public. It also included an act that passed the Senate in June, and so we're going to cover more of those things in greater detail. On January 27th, that executive order was released. The title of that is Tackling the Climate Crisis at Home and Abroad. This laid out a series of actions for federal agencies to take regarding climate change, mitigation, and resilience. So this directly included the Secretary of Ag, who, like I said, has been collecting stakeholder input on climate smart ag and forestry. So what does climate smart ag mean? Those are activities or practices that store carbon, improve resilience and soil health while reducing greenhouse gas emissions. This is a picture that was showed earlier on that puzzle piece. You can see how this field is going to be more resilient if I can get more water, if I can get more air. Which crop do you think is going to do better in the middle of summer if it's a drought? It's going to be this one here on the left. So it's going to be more resilient. Or I guess I should say on the right. So then some of those examples include reduced tillage, no-till, cover crops, fertilizer management, prescribed grazing, among a host of other practices. One of the reports that's been released is this 90-day progress report on climate smart ag. There were 7 objectives that were identified in that report. The one I'm going to focus on today is leveraging existing USDA programs to support these climate smart ag strategies. It also included quantifying, tracking, and reporting the greenhouse gas benefits associated with those practices, strengthening education and training, research, improving market availability, and forest and wildfire strategies. So the Growing Climate Solutions Act passed the Senate on June 24th of 2021. This bill addresses the lack of regulation and consistency when it comes to these carbon markets. The goals of the act are to help producers understand and access the carbon markets, to provide technical assistance to those producers who are trying to overcome the barriers to entering that market. It will also set up a third-party certification process and creates an advisory council that includes a wide variety of stakeholders, including farmers. At the end of September, USDA had another public comment period that ended on November 1st. The goal was to get comments on these new initiatives that they are proposing for the climate smart forestry and farming practices. This will help them create a set of pilot projects that will provide incentives to incorporating these practices on working lands. And it will also monitor the carbon and greenhouse gas benefits associated with those. Another initiative is the America the Beautiful initiative. This is an effort to work collaboratively to conserve 30% of the lands, waters, and wildlife in the United States by 2030. This report has been generated after getting input from a wide range of stakeholders, and there is a set of preliminary recommendations for locally led and voluntary conservation. So now I'd like to focus on some of the climate change activities that NRCS is currently involved with. In Iowa, we're going to focus on soil health, nitrogen stewardship, conservation of sensitive lands, grazing and pasture lands, and energy efficiency. That's not an all-encompassing list, but those are some of the things that we're going to focus on. Moving forward, we want to enhance the ability of our programs to help people adopt those practices. There will also be some efforts centered on quantification, increasing education, and supporting the markets. Some of our programs, such as the Environmental Quality Incentives Program and the Conservation Stewardship Program, are going to be at the center of some of these efforts. So there is likely going to be increased funding with both of these programs. The goal with these financial assistance programs is to help farmers work through the learning curve that's associated, especially if you are thinking about changing some of your management practices on your farms. There's a learning curve that's associated with that. And these cost share contracts will help mitigate some of that risk while you go through that period. So that's something that we will be focusing on. We also have something called the Conservation Innovation Grants. Those are programs that help with the development of new tools and technologies. Our partners work to incorporate those tools and technologies to help address some of our resource concerns that include air, water quality, soil health, and wildlife habitat. It includes opportunities such as the national and state options. It also has on-farm conservation innovation trials. Some of our resources include this Climate Hub website. I'd encourage you to go to this website. There's a lot of resources on there. There's one website for each region across the country. So this is a snapshot of the Midwest Climate Hub website. It's got some references on there on how to improve the resiliency of your farm and some interesting information on how the weather has been changing across the Midwest. We also have a model that can help you. You can input your current practices, you can identify your location and input what potential practices you might implement, and that will give you an idea of how much carbon they are anticipating that you might be able to accumulate in your soils. Now, there is a difference between soils and how much carbon each can accumulate. For example, it's harder to accumulate in sandy soils versus a soil that has more clay. So these models take that information into account. They are pulling in data from thousands of data points. They are using that information in addition to the information that you input to try to predict what the outcome will be on your farm. So you can go to one of these commentplanner.com website to plug in your information, and you can get an idea of what might happen on your farm. So example, this is what happens when you reduce your tillage and you incorporate or sequester more carbon dioxide into your soil. Those negative results indicate that emission reductions or carbon sequestration is happening. One of the main focuses of NRCS over the last several years has been soil health, which is, like I said, intricately related to the carbon markets and carbon sequestration. So there's a lot of information online with soil health options, and staff in the field offices, myself, there's area soil health specialists that would be happy to meet with you on your farm to help you think about what your goals are as you think about potentially changing some of your management practices and incorporating more soil health into your system. So in conclusion, I went through a lot of different factors here, from carbon and the markets and soil health and the resources. But one thing I want you to remember is that soil is composed of a lot of different things, but carbon is the glue that holds everything together. So it's critical, and whether or not you decide to enter the carbon market is up to you, but if you can increase the carbon or the soil organic matter on your farm, it's going to increase the productivity and the soil functions on your farm. Here is my contact information. I would be happy to chat with anybody about options on their farm. And with that, I will turn it back over to you.